living on a disk, floating through space, with a tiny sun.
Hey, I'm FTFE, welcome back to the channel that pushes stupidity down the stairs of knowledge. We have an early debate tonight. I am not going to be up till 4 in the morning for a change. Mr. Sensible asked me to host a debate between him and Mitchell from Australia. So let's just get straight into this. We tossed a coin beforehand and we found out that Mr. Sensible would be introducing himself first. So why don't you just take a few minutes and say hello to the folks.
Hello. I am getting some buffering, I'm afraid, right now, so hopefully that will sort itself out. I'm Mr. Sensible, got Arnold, and we've had a couple of ding-dongs with Mitch from Australia, and so we decided to have a bit of a debate, and Fight has kindly agreed to host it.
Awesome. Right, why don't we just go over to Mitchell from Australia, and Mitchell, welcome to the show. Thank you for joining. Why don't you introduce yourself to the folks?
Thanks, mate. Mitchell from Australia. My name's Mitchell from Australia. Pretty self-explanatory. You can find me on YouTube. Mitchell from Australia. I also co-host a podcast with Paul on the plane called Dome Life. And it's pretty much me in a nutshell.
Awesome. Right, so why don't we just get straight into you guys having a conversation. You've both got evidence that you'd like to present. So, Mr. Sensible, do you want to present some of your evidence first?
Okay, so we've got 5 minutes each, 5 minutes to present and 5 minutes to debunk.
Yep.
And I won the toss. Right, well, the first evidence I'm going to go for is all to do with star rotation, which I think is pretty much a killer for the flat Earth. As we all know, the stars in the Northern Hemisphere all rotate around the circumpolar point, which is pretty darn close to Polaris. Not exact, but pretty close. And if you were at the North Pole, that would be obviously straight overhead. The stars further and further away from... Oh, I've got a timer going off. the further you get away from the North Pole, Sorry, let me go back a bit. That distracted me. While you're under the pole, the stars are all rotating around. Those stars near the horizon are rotating right around the horizon. They're all going in circles. As you move away from the pole, for each 69 miles, the circumpolar point drops by about 1 degree, but all the stars are still rotating around it. The stars that were nearest the horizon start to dip under the horizon. Now, as you get further and further south and approach the equator, those stars are now arcing over the north circumpolar point until you're on the equator, and the star Polaris will be at the horizon with all the stars looking northward, rotating in arcs around it. If you were to look due east, the stars would rise vertically. Due west, they'll set vertically. But if you turn to the south, you've got a second point of rotation, which I fail to see can work on a flat Earth. So a wheel or a flat disk has a single point of rotation. That's what you would need if you had stars in a flat plane above a flat plane, or indeed a dome rotating above a flat Earth, a single point of rotation. Whereas the Earth, a three-dimensional shape, say like a block of cheese, would have 2 points of rotation, my left and right hand. That's just due to its basic shape, its geometry. Whether it is a block of cheese shape or a globe or any other shape, you're going to get 2 points of rotation, which is what we see in the sky with the stars rotating. Telescopes use equatorial mounts. You line the telescope up to the circumpolar point, which is pretty straightforward in the north, because you're pretty much aimed at Polaris. Not quite, but pretty much. And once set up, the telescope can just rotate following the stars, and it will follow them even to the point that it could point at the ground. That wouldn't work on a flat Earth. And of course, as soon as you go beyond the equator, so that Polaris is hidden, you can no longer point at that. So you point at the southern circumpolar point, Sigma Octantis. Again, how would this work on a flat Earth? It just doesn't, but it works perfectly on a sphere. And I'd like to actually just use what I think is a favourite of Mitch's, modus tollens. If P, Earth is a flat plane, and the stars rotate above, then Q, there will be a single point of rotation of the stars. Not Q. There are 2 points of rotation of the stars, therefore not P. The Earth is not flat. To be honest, with regards to star rotation, I think that pretty much does it, because equatorial mounts don't work on a flat Earth, or I'd like to hear a damn good explanation of how, and we have those 2 points of rotation. So at that point, with regard to star rotation, I think I'm happy to call it an end, because I'd like to hear what Mitch has to say about that. I don't know what my time is. I did have a timer, but it misfired.
It's about 5 minutes. So
Cool.
Why don't we go over to Mitch and let him give his kind of opening statement, and then we can just get back and forth into talking about each other's evidence. So Mitch, what have you got for us?
So what is the basis of your claim? Are you coming at it from a globe-proof perspective, or a flat Earth disproving perspective?
Actually,
What
both.
is the claim?
Both.
All right, do you want to start with the globe? Okay.
Well, if you were following a path from the North Pole, going further and further south, then you've got that northern point of rotation dropping by 1 degree every 69 miles, I think, pretty much. And once you reach the equator, you get the southern circumpolar point rising again by 1 degree for every 69 miles. And if you carried on, you'll eventually reach the South Pole and have the southern circumpolar point directly above you. You carry on in the same direction, and that starts dropping. And eventually, when you pass the equator, the northern circumpolar point around Polaris will be rising again until you've made a full circuit. But as I said, with a flat object, you've only got one axis of rotation, and yet we can see two, unless you're denying that looking south, and you are in Australia, looking south, the stars would wheel around that point near Sigma Octantis.
Can I ask what model that's based on for the flat Earth? Because I don't actually present a model. I don't support the AE model. I don't hold it up. I don't say this is what happens. But is that what it's based on? The AE model?
Well, any flat Earth, whether the flat Earth is square, diamond shaped, whatever, if it's a flat object, then how can you have 2 points of rotation in the sky? One in the north, one in the south.
Okay, so stars rotating.
Yeah.
What's this caused by?
It's caused by the Earth. The stars aren't rotating. The stars, in effect, are still.
Right.
We are rotating.
So the Earth is rotating, making the stars look apparently rotating, correct?
Yes.
Okay, so other evidence for the Earth rotating can be described by the Coriolis effect, correct? Like you have
with
a
the
pendulum
Coriolis effect,
swinging.
the Foucault pendulum, yeah, that would back it up as well.
Yep. So the premise of the Foucault pendulum is that the Foucault pendulum is in the fixed inertial reference frame, non-rotating, and the Earth turns underneath the rotating inertial frame, correct?
The pendulum swings back and forth in a straight plane, but when you look at that straight plane, when you look at how it appears on the ground, if you like, it appears as though it's rotating. It's not. It's remaining in the same frame.
Apparent deviation from the Earth spinning.
Yes.
And also optical gyroscopes.
Optical gyroscope. Yeah, 15 degrees per hour. Thanks, Bob.
Yep. Thanks, Bob.
Cheers, Bob.
No bell for no Dell. Yep. So if this were true, that the Earth is causing these things to apparently rotate. That's a great image up there. So that can also be true for things like hot air balloons, for drones, for things that are definitely not fixed to the spinning reference frame of the Earth. So we should see Coriolis.
I'm not quite sure where you're going with this. I mean, the stars appear to rotate above us. The point being, they
That's
rotate
correct.
in the northern hemisphere. I was going to say they appear to rotate around Polaris.
Caused by the spin of the Earth. And if the spin of the Earth is true, we should see Coriolis on all objects, not attached to the spinning reference frame of the Earth. So for a hot air balloon or a drone that go up from the Earth, they are now in the inertial reference frame, with the Earth spinning underneath in the rotating non-inertial reference frame. And we do not see Coriolis underneath hot air balloons. We don't see Coriolis underneath a drone, underneath a plane, or anything for that matter. It is asserted that these things are caused by the spin of the Earth. So
balloons just travel with the atmosphere. The thing is, the atmosphere is travelling with the Earth. With something like a drone or other powered vehicle, they're also carried in the atmosphere. If you were flying from the pole south towards the equator, what you are saying is the Earth would be turning underneath you. So if you went following the 0 degree meridian, hoping to go down and across Greenwich, the Earth would have rotated away from underneath you. The thing is, that aircraft is also moving along with the atmosphere, and it's a powered vehicle, so it's continually making adjustments anyway.
I feel like we need to bring it a little bit back on topic. I think Mr. Sensible's claim was not really to do with the Coriolis, just the star rotation.
It was to do with the spin of the Earth, and that's where I'm getting at. So I absolutely agree with Mr. Sensible. We don't see Coriolis, and that would.
Well, we do see Coriolis. Look at storms north and south of the equator. They rotate different directions, but with the stars in the north, they're rotating in circles around the north circumpolar point, and yet you go beyond the equator southwards, you've got a second circumpolar point. That's physically impossible with a flat Earth, whatever the shape of that flat Earth.
Okay, I'll try and make this more concise. So we see star rotation because the Earth spins. And if the Earth spins, we should see the Earth spinning underneath other objects in that inertial reference frame that's not attached to the Earth. So if
aircraft and balloons and stuff, they're in the same reference frame because the atmosphere is rotating with the Earth.
So we do not see Coriolis in those things. We do not see Coriolis in things that are apparently still rotating with the Earth. So if there is conservation of angular momentum, we do not see Coriolis. Therefore, we can't assert that all things with this apparent deviation are caused by the Earth's spin. So if it's true for star rotation, if it's true for Foucault pendulum,
the stars aren't in our reference
we should
frame.
See it.
The stars aren't in our reference frame.
That's correct. They're in the inertial reference frame. With the Earth
we are rotating.
Underneath.
Yes, the Earth is spinning, and the stars appear to rotate because they're not in our reference frame. The atmosphere is in our reference frame.
Okay, I'll try and make it more concise then. I'll put it in Modus Tollens for my argument. If the Earth spins, P, if P then Q, not Q, therefore not P. If the Earth spins, we must see Coriolis on all objects. We do not see Coriolis on any object, I would assert, so the Earth does not spin.
Hurricanes, north and south of the equator, rotate different directions because of Coriolis.
So Coriolis is an apparent force. This force that is asserted to be put onto hurricanes and cyclones is an actual force. We actually see them rotating.
Because the atmosphere isn't rigidly attached to us, so there is It's not drag, but in effect, it's a drag sort of effect. So the north of the equator, the drag is, for want of a better word, is higher on one side of that air movement than the other. So that gives you the rotation one direction. South of the equator, it's the other direction. And you can look
with hurricanes,
images. Well, I was going to say, you can look at images of hurricanes or tornadoes, whichever, and they rotate the opposite direction. And if one crosses the equator, which can happen from time to time, they'll then tend to peter out that much faster because they're fighting against that. But
so
this
hurricanes
is still,
spin.
you're keeping away from stars, Mitch. I want to hold you to that. There's still no explanation for two rotation points in the sky.
Because I don't have an explanation for two rotation points in the sky.
Okay.
That's asserted because
fair enough.
Because it's asserted that we live on a globe with two opposite poles, and
well, it's not asserted. Look out your window at night, or go in your garden at night. Look southwards. Those stars rotate in one direction. Look northwards, and stars are rotating the other direction. You know, if you can see the northern circumpolar. Okay.
No,
I think that absolutely proves. We've probably come to an end.
Mitch said that he doesn't have an explanation for the counter-rotating stars, which is fair enough.
Okay. Yep, definitely.
So maybe we could just ask Mitch to present some of his evidence, and we could quickly discuss that.
Yeah, cool. So do you want to play that first video, please, without the audio?
Yeah, sure. Let me just get that up.
Which subject are we doing first, Mitch?
So the black swan.
Okay.
All right, so I'm not here to present flat Earth evidence. That's a conversation we have after the globe is conceded, because I don't see that holding up two different models in false dichotomy is going to prove anything. You've always got a false model, and you've always got no model proves anything because it's just a model, it's a concept. And so this black swan here, everyone should have seen it. It's an observation from 1 foot. You've got the horizon line in the distance past those two platforms. Those platforms are only markers. So 9.4 miles is the furthest platform we can see with the horizon in the distance. So from this image, we can assert that the Modus-Tollon argument, using spherical geometry, there must be a geometric horizon, and that does not change. So using Modus-Tollons, if P then Q, not Q, therefore not P. If we have a globe with a radius 3959 miles, then Q, every single geometric horizon must be no more than 1.22 miles times the square root of the observer height in feet. And that's fixed. That's your physical spherical horizon that blocks ships, that curves with altitude, and that makes things disappear with distance. This is fixed. And this image here, the black swan, could you put up slide 1, please, Flutter?
1 sec.
Without the horizon line?
That one?
No.
Oh.
No, that's number 2. Number 1 is just the image of the black swan without the horizon in it.
Where's that
without
one?
The line.
I don't think I got that one loaded in.
So
I think I may have.
P.
That sounds like it might be my image number 5, Craig.
Wait.
Yeah, you can put
that
that
one.
in. Yep,
My bad.
That's fine. Fantastic. So if P, then Q. If P, we have a radius of 3959 miles, then Q, every single horizon must be that measurement. Not Q, we have the black swan. The horizon is far in the distance. Then not P, we do not have a globe. And I'd like your response to that.
Okay. Just quickly, a lot of people in the chat are asking me to challenge Mitch. This isn't my debate, guys. I'm just here to moderate and facilitate what's going on. The conversation is between Mr. Sensible and Mitchell from Australia, so I'm going to let them have the conversation and keep out of it as much as possible and just be a moderator. So as long as everyone understands that. But yes, Mr. Sensible, could you respond to that?
Okay, well, I'd like to start off, if you could load image 5, please.
Okay, so image 5, this one, yeah?
The crisp horizon. Yes. So these are the same two platforms with the photo taken on a different day. And as you can see, the horizon is in front of the two platforms. And in fact, the furthest platform is half hidden. Now, that's obviously different. Something has changed. That's all to do with refraction. If you had a flat Earth, you would never, ever, ever get a crisp horizon like this, because there's nothing getting in the way. So in effect, you'd see pretty much forever, and it would fade off into the distance. So we got the image that Mitch showed with the horizon, with a horizon in front.
Oh, Mr. Sensible seems to be cutting out a little bit there. Are you there, Mr. Sensible?
Hello, hello?
Yep, sorry, you cut out for a second there. Could you just repeat like the last 15, 20 seconds of what you said?
Sorry, say again?
You cut out a little bit there. Could you just repeat the last 15, 20 seconds?
Okay, I was just saying that on a flat Earth you'd see forever. You'd never get a crisp horizon because things would finally fade off into an unresolvable blur. And there's a difference between the two photos, this one here and the one that Mitch showed. The horizon has apparently changed. Now, the physical Earth has not changed, does not ever change. That is a fixed geometric shape. So something else has changed. That's the atmospheric conditions. That's the only explanation that's possible. So if we can go on to, I think it's image 6. Oh, actually, you're showing image 6 anyway, aren't you?
Yeah.
Yeah. So if you could show image 5, that was just a general. Thank you. Just a crisp horizon, which you could never see on a flat Earth. That there is an apparent horizon. We don't know exactly how far away it is. We don't know what the refraction's like on that day. But it's a clear day, and it's a crisp, hard horizon. If the Earth was flat, the ocean. The view of the ocean would continue because there's nothing to block it, and you'd end up with a point where it comes to an unresolvable blur. So yeah, it's the apparent horizon that's changed. I can't see an explanation on flat Earth for that. Now, what I have done, Mitch, is I've done something special for you. I decided to do a little experiment, which I've videoed. It's got sound, so I wonder if you can just play YouTube clip 3, and it's all to do with refraction. Thank you.
Right,
with sound,
you need the audio on this, do you?
Yes, I do.
Let me just check which one is the start one.
Over here, we have a little tack with a white paper on, a little flag. Here we've got our sphere with our platform on, and we've got this blue area which is beyond the horizon. It can't be seen on the close-up footage. So what we'll do is we'll introduce some refraction. I'll keep the camera running in the corner so you can see the whole thing. So we've got our view of the platform just in front of the horizon, the physical geometric horizon, and you can't see the blue which is beyond the geometric horizon, and you can't see the white flag either. Here comes our refraction, distortion. There's the platform, and as we change it, you can just see the blue that's beyond the geometric horizon and the white flag behind it. There it goes. Here it is. Refraction will bring things beyond the geometric horizon. Black Swan busted.
Okay.
I'll just let that play again whilst you talk.
Okay, that's fine. Yeah, so because obviously I'm only a few inches away from the ball, the geometric and apparent horizon on that ball is going to match. As soon as I put that lens in front, that's the equivalent of having the atmosphere there, because without that, in effect, there's no atmosphere, geometric and apparent match. When we put the lens in front, we're causing refraction. The ball is not closer, the ball is not further away, the platform, the tack is in the same position, but suddenly we can see around the curve. The horizon has apparently lifted. Once this gets to that point in the video, as the lens drops, watch the horizon that's just behind the platform lift, just as it has on those gas platform pictures that Mitch showed. That horizon is now apparently higher. It physically hasn't changed. The ball hasn't moved, hasn't changed size, nothing. It's only the distortion in the air. Now, either you accept that there is refraction, in which case things change, as we've seen between the crisp image of the horizon in front of the platforms and the blurry, distorted image with the horizon behind the platforms. So either you accept that refraction has an effect, or you don't accept refraction, in which case you need to explain why some days the view is different than other days. And you saw that white flag, that little piece of white paper, which is behind the ball, was lifted into view, which is the equivalent of the sun. When the sun sets, it physically is below the horizon. A short while before, it visibly is below the horizon. So I think that Nathan Oakley, Quantum Eraser, Sleeping Warrior, and you, Mitch, your Black Swan is busted. I've just proved that refraction can lift objects and lift the horizon.
So would you say that's looming the horizon above the horizon?
Yeah, absolutely. It's looming. Well, it's looming the whole area beyond that tack. I mean, a horizon isn't a physical thing. It's just the point at which geometrically the tangent that you're looking at towards the surface of the Earth meets the surface of the Earth, so you can't see anything beyond it. With the refraction, that has changed. The light waves, the light paths have been bent, so you can see further. So you have moved the horizon apparently further away. And we never, ever, ever see the geometric horizon, because we're always looking through atmosphere, which always provides distortion to a greater or lesser extent. And I think that's it.
Okay, let's let Mitchell respond to that.
That is a great distorted view of refraction. So what is actually causing this refraction? Is there atmosphere around that ball you have there before you put the lens up to it?
Of course there's atmosphere.
There was no atmosphere there.
No, I'm saying it'd be the equivalent of having no atmosphere, because I was only I was less than a foot away from it. So, well, no, it's not, Mitch. That's true. But we're talking about a foot. The amount of refraction you'll get in the air over a foot is, well, there's going to be some, but it's going to be so minuscule. I bet you couldn't even measure it. Whereas with those platforms, that 6.5 and 9.5 miles away, you've got a lot of air. So those light waves are being slowly bent or gently bent over a long distance. You can forget what I said about no atmosphere if you want. Yeah, go on.
That's fine. But I can point out that it's definitely not anything to do with air or atmosphere that you're using to refract that geometric horizon of that ball above where it should be. No, you've got a physical lens there.
I have got a physical lens, yeah. And lenses work by refracting light. So unless you're denying that the atmosphere can refract light, are you denying that the atmosphere can refract light? Because if so, you're going to have to explain mirages.
I think I should show a video of actual refraction. Can you play the video number 3, please, Craig?
That's this one, yeah.
So we've got a physical edge of this canister here with something off in the horizon, past that horizon. And so when the guy pours on some butane, some liquid butane, we're going to see a different color from over the horizon. And notice that the horizon of that gas canister is not moving. We do not see a refracted horizon above the horizon. The horizon doesn't change. It does not get refracted. To say that a horizon looms above horizon is a contradiction in terms.
But I've just shown how and what he's doing there, and I've seen that before, and it is a great example of refraction. So obviously you accept that there's such a thing as refraction then. I guess you agree on that. Okay, well, that's cool. So we don't have to
Absolutely.
argue about that.
Yep.
Yeah,
So-
so the only issue I'd have with this, and I think it's a wonderful experiment that proves refraction, the only issue I'd have to say is, as you can see, as he pours that butane on, yes, you can see refraction, but then it's gone just a second or two later. So that's one aspect. But also that, I don't know what distance he is away. I don't know how he would do it to show it over a longer period. Do you see what I'm saying? It's very quick. And to my eyes, I'm trying to be fair, but to my eyes, it looks as though that horizon does move a little, but I can't prove that.
Let me see
No,
if I can zoom in
it
on a bit.
doesn't.
You
You can zoom in as much as you want. The horizon does not move. So when you're trying to,
Video.
so this is atmospheric refraction, and this is more refraction than you would ever see over any distance.
Well, what I've just thought, Mitch, that as he causes the refraction, you can see I think it's a red area. So that red area right
Yep.
now is hidden behind the horizon, the physical geometric horizon.
Behind the
yes?
physical horizon.
Yeah.
Yep.
Now, on my example, I had the tack was actually just in front of the physical geometric horizon, but there was the blue area behind, which then is pulled into view. So he is pulling something that is beyond that. The equivalent, he's pulling that red, which is beyond the geometric horizon, just like my blue area was beyond the geometric horizon. He is pulling that into view. But I see what
Correct.
you're saying. You're saying about the actual physical, the actual line of the horizon as well, because what we can't. So I mean, I don't know how far around the curve that thing is, because that blue on mine was only just behind the curve. When he's pouring that butane on, yes, it's lifting the red. Is it lifting some just in front of the red, which is currently hidden? I don't know.
So this is looming. The definition of looming is an object, not the horizon. Horizon does not loom. An object being brought up from over the horizon or appearing higher in elevation than it usually is.
The horizon isn't an object. It's just a point a certain distance away from you. I mean,
Correct.
the blue area on mine, the blue area of mine, at some point in that refraction I showed, became the apparent horizon. And, well, it was right on the apparent horizon. There you go. Thanks, Craig. You can see that blue area there is now the apparent horizon. That has been lifted by the refracted light. So there you go.
So this
you can
physical
see,
glass lens,
which is just
physical glass
refraction.
lens has nothing to do with atmospheric refraction. We will never have a physical glass lens to look around the edge of a globe.
No, we can't. We
This-
wouldn't.
this is-
That physical glass lens is representing a distance in your photograph of 9 or 10 miles of atmosphere. Atmosphere does. I mean, you've just shown that refraction is real. This lenses work by refracting light. The point is,
Not like this.
that area of blue. Well, that area of blue is behind a curve. So how did that lens lift that area of blue from behind the curve?
Yeah, I'm not
It has
concerned what a
refracted the light
physical
path.
glass lens does. I'm concerned what the actual atmosphere does, and the actual atmosphere does never ever loom anything. It looms objects. Sorry, it never looms any horizons. And the horizon is geometric. It is physical. It does not loom above the horizon on the globe.
So
you have physical
Well,
geometry.
in which case then, Mitch, the two photos of the platforms, your one with a horizon behind it and my one with a horizon in front of it,
Yep.
what's changed? How can that be different if the quote horizon never looms or is refracted?
the horizon-
Because those are different horizons.
Absolutely. The image that you show is a white swan. Do you understand the black swan argument?
Yes, I understand a black swan. So what? Explain yourself.
So the analogy of the black swan is that if we say that all swans are white, which is the image that you show of the platforms being cut off, which is images of boats being cut off by the horizon, images of
Yep.
a physical geometric horizon cutting things off. And so this it only needs one black swan to prove that the geometric horizon is not there. That's what this black swan image is. On a different day, which this black swan is on, we can show that the geometric horizon should be at 1.22 miles here, but it's not. And it doesn't matter how many white swans you show, it's never going to make the geometric horizon be geometric again.
The point is that horizon, the apparent horizon, changes. Therefore, you can never be sure you're looking at the physical geometric horizon. I mean, if you look at the Earth curve calculators, they actually state, I've actually got a quote here, one second. Actually states,
do you want to put the second, I've got an image of that. Do you want to put the second image up, please, Craig? Yeah, that. Earth curve
it actually
calculator.
says on the Earth curve calculator, it's not accurate for observations over water, very close to the horizon, unless the temperature and vertical temperature gradient are accurate. It uses standard refraction, which is an approximation of the refraction expected under standard atmospheric conditions. So basically,
so what's
that Earth curve calculator. So go on.
I was going to say, what is standard refraction? Is that the 7/6R?
Right. I'll have to say, once you start getting into the maths, that starts getting difficult for me because I'm not a mathematician. But the point is, refraction varies. But there is your norm, what you normally see. But every day it varies a little. Some days it varies a hell of a lot. Hence things like the Chicago skyline, which you can't normally see. On those very odd occasions, you can see it because it has been refracted into view.
So they're objects refracting over the horizon. The horizon never refracts over the horizon. Even your subject matter expert, Andrew Thomas Young. Sorry?
We just seen in your photo that horizon has moved. It's a new apparent horizon on your Black Swan photo.
Forward. The horizon can always move towards the observer. Horizons can always move towards the observer due to fog, due to those atmospheric conditions, due to sinking, which is the opposite of looming, that makes objects appear to be lower than their actual elevation. But the horizon will never loom above a horizon. You've always got a geometric horizon. So that's what you assert. So when we see that horizon in the distance, is that visible, or is that apparent?
Sorry, I talked over that last bit. What did you say?
Okay, you can go on your point.
Well, I was just going to say that the horizon, the ball of the Earth, has physical dimensions from any given height.
Correct.
If you had no atmosphere, you could only see. So if this view here was of the Earth with no atmosphere, you would only see as far as the geometric horizon, never more, never less. As soon as you bring an atmosphere in, you're distorting. It's like looking through glass. To one extent or another, it's distorting. So it changes the apparent view. It lifts and drops it, just depending on the amount of refraction. Now, on occasions when there's a lot of refraction, you can start to see things from around the curve. Simple as.
So as I demonstrated with my video, you can absolutely see things from objects from over a horizon. Yep, but the horizon never looms.
Well, what would be interesting, I do apologise for jumping in just there, Mitch, since we're looking at this video, but what would have been interesting is if that object there was placed either just on or just in front of the horizon, and then he does the butane to see if, because then we'd have something to measure it by, to see if the horizon sort of just behind it actually does lift in relation to that object. That would be interesting. That might answer this either way with regard to this video.
Well, I think it answers it anyway because it's using atmospheric refraction, whereas I don't know what you were using with a physical lens. We're never going to see that. That's actually raising the observer height. So
no, it isn't. The camera did not move. I'm going to have to stop you there because that whole experiment was filmed in one shot from the picture in the corner. Yep. That camera on that phone never moved. The ball never moved. I did not change the position of either. Its point of view was identical. You can see there, I'm dropping the lens up and down between them.
Yep, so you got a piece of of physical glass that's above that lens that you're going to see from around that curve. That glass is going to be above the observer height of the camera. So you're changing the observer height with the glass. You're not moving the camera. You're using the glass.
The point of view of the point of view of the camera is absolutely identical the whole time. It does not move. I'm bending the light rays between the camera and the sphere with the platform with the area beyond. I fail to see, unless that is refracting light, I fail to see how you can see around that curve, because that now is no longer in view. So how can you...
Can you just detail what sort of refraction that is? Is it atmospheric refraction? Is it standard refraction? I'm not sure what you're trying to say. That
I have bent the rays of light. Lenses work by refracting light. So it's not going to be...
So there's...
go on.
There's so many different types of refraction. Do you know any of the atmospheric refraction types?
We get looming, you get Fata Morgana. Yeah, you get Fata Morgana, that's another one. You get towering.
Yep, towering, stooping, sinking, looming, mirage. There's 5. So would you assert this is looming?
I don't care about the definitions. The point is that
I know, that's my point. So you not caring about the definitions.
You get objects lifted into view.
Guys, let's try not to talk over each other, if that's okay. Mitchell, you just finish what you're saying there and let Mr. Sensible respond after that.
Okay, so my statement is still true. It's still a logical consistency. We have a horizon of the black swan far past that geometric horizon. Horizons cannot loom up. Horizons can sink down. That's why we see all the white swan images. That's why we see boats being cut off halfway, not due to physical edge, because there is no physical edge. We never see a geometric horizon. A geometric horizon is only a thought experiment. It's conceptual. We never see it. It's apparent. All horizons are apparent. And that's what the black swan is.
Sorry. You have said...
So the black swan...
All right, go ahead, Mr. Sensible, if you could respond.
Yeah. You have said that it lifts objects, yes? Such as buildings, mountains, whatever it is, or platforms. It has lifted an object. It's lifted the surface of the water. There's no difference between a boat sat just beyond the horizon, which is lifted into view, and the water itself. And if you're lifting the water itself, you're changing the apparent horizon. It's like having a curve of paper and straightening it up a bit. You're seeing more of it. It's being lifted around a curve.
So I'd say it's like a gas bottle with butane poured on top of it. It doesn't get refracted around. That's how refraction works. I've demonstrated how refraction works. It refracts objects, not horizons.
But the surface of that butane canister or the surface of the sea is an object. It's something that its position can be changed. It's being the light rays from it are being deflected. They're being bent. They're being refracted. So your view of it changes.
It seems like we're agreeing on this point because not Q, we don't have a geometric horizon. Then not P, the Earth is not a globe.
We do have a geometric horizon. We just can't see it. But perhaps we better agree to disagree. But I would like to see that butane experiment done. I would like to see that butane experiment done again with the object or another object just in front of that geometric horizon, so just so you could really stand a chance of seeing if there is or isn't any movement in that horizon. That would be interesting. I hope you'd agree with that, because it should rule it in or out, perhaps.
Absolutely, but by definition, you are not going to see a horizon being moved. It is geometric on all accounts, unless you're acknowledging that it is apparent.
I'm not quite sure what you're saying.
So in the black swan image, okay, can you put the black swan image back up, please?
Yeah,
Craig?
1 sec.
So that horizon you're seeing there, what is that horizon? Is that physical or is that apparent?
It's apparent.
Exactly. So where's the geometric horizon?
At some point in front of it.
Do you want to point to it? Do you want to give me a pixel?
You can't.
Where it would be? No, you can't.
Okay. No,
by
you
sh-
can't because you hold on. You can't because you can't see it. It could be right along the line of the top of that text, for all we know. It makes no odds. The point is, let's say it is along the line of the top of that text where it says platform habitat and hill house. But due to the refraction, the area beyond the top of that text has been lifted, uncurled. If that was just a curve away from, well, that's a curve away from you. It's been uncurled a bit so you can see further. There is no the horizon. There is a geometric horizon, but if you walk forward 6 feet, the geometric horizon would move away from you by 6 feet. It's not an exact point. It's just a distance.
So that's apparent. It changes.
Well, if you're standing still,
Correct.
it will never ever change.
Well, it came from atmospheric conditions, as I've shown here in this black swan, and as I've shown in the butane over the gas bottle video. It absolutely does change, and we're not walking towards or away from it.
Sorry, what
So
changes?
can I ask, the horizon can come closer to us due to atmospheric conditions, but it
So
cannot go
apparently,
further
it's
away from
apparently in one place one day, and apparently in another place another day. And how could it be different
It's always
if not for
apparent. That's what the
refraction?
definition of a horizon is. It's an apparent location. So if you say the apparent horizon, the word apparent is redundant. The very definition of horizon is apparent location. So you're saying apparent location. But can I ask you, if it is an apparent location, the horizon, what is cutting off the bottoms of those ships?
Sorry, when? What, like your picture of the clipper ship with the five?
I think Mitchell's question is if the horizon is apparent, why do ships appear to disappear bottom up? Is that right, Mitchell? I don't want to strawman you. Is that correct?
Correct.
Right.
Because on occasions when you see that, the ship is beyond the geometric horizon, and the amount of refraction is not enough to lift them further into view. So the geometric horizon is hiding them.
So we can see the geometric horizon on some days?
Well, it may be that the geometric horizon is nearer still, but the point is, if you had a geometric horizon, let's just say at 2 miles, just for the sake of argument, and the ship is 3 miles away and half hidden, or would be half hidden, with the amount of refraction on that day, it may lift it up a bit, but not all the way so you can see the whole thing. So some of it is hidden.
But the point is, what
By
the point
the
is
apparent
what
horizon.
is hiding those? What the horizon is hiding it. So a non-physical thing is blocking something.
No, it's hidden behind the water, but there's not enough refraction to lift the image of the full ship above that apparent horizon.
Craig, do you want in on this? Because is this your image? K values?
This is just something that it explains about why the horizon can be looming. I'm not getting involved. I'm just putting this up for reference for everybody that's watching.
If it's all right with Mr. Sensible, you can have your opinion on this too.
Yeah, I'm
this is
fine.
a
I'd
widely-
appreciate some input. Yeah.
Oh, my
If you
position
want, Craig.
is that the horizon most of the time is apparent, unless the K value matches what the curve of the Earth is. Then you will be seeing the geometric horizon. I mean, but that is obviously depending on the lapse rate and the coefficient of refraction. My personal opinion is you see things go over the apparent horizon.
Always. Do you ever see it go over the geometric horizon?
You would see that if the K value matched the curve of the Earth. In that specific instance, you would then see the geometric and the apparent horizon would be the same. But obviously, depending on the coefficient of refraction, the apparent horizon can shift. I mean, as this graph says, there's times where if the K value is below 1, so -1 or -2, then the horizon can actually appear as though it's concave, which has been demonstrated in my recent debates with a few concave earthers. So, yeah, the apparent position of the horizon can change quite a lot, but that is what we see. We see the apparent horizon. Unless the K value matches what the curve of the Earth is, then we will also see the geometric horizon. But obviously that is very specific circumstances.
Yeah, I'll just say you never see the geometric horizon. Therefore, in the black
you're
swan
asserting
image,
it because you're saying there isn't one.
because there isn't one, the black swan image proves that, because horizons cannot be loomed up above horizons. Is that what you're asserting here, Craig? That the horizon is being moved up above the horizon?
In certain conditions, yeah. When there were some researchers that were doing these observations in around the Antarctic Circle, and the K value was actually about -16, and it literally made it look like, you know, they were on halo and it was rising up in the distance. So the horizon, the geometric horizon, is still a physical thing. So I don't know if that would be excluded from things looming. You know, the horizon is still a thing, so I would say that the horizon can also be loomed because it's a physical thing. That's what the apparent position is. But this isn't my debate, and I don't want to get into it. I would love you two to have this conversation. Mitchell, you and I can definitely have a conversation on another day, because I've studied the maths of this quite a lot.
And that's where we find ourselves with this. We find globe earthers like yourselves arguing for an apparent horizon when you need a geometric horizon. You show that K value on a model using Muppet vision on the side of the model. That's the same maths that you use to predict on the Earth curve calculator where that geometric horizon is, where the curve of the Earth is blocking things. So
But
when we have the black swan image, so the black swan image disproves that there is any.
Sorry.
The black image disproves that there is any geometric horizon. It is not there on one day and not there and there on the next day.
Right.
It's simply not there. So
I think everyone's agreeing that there's an apparent horizon, and the conversation has started to circle round. So why don't we move on to another topic?
Yep. Is it
so
me
back
next?
to my logical consistency, just to finish off.
Yep, fine.
Yeah.
Not Q. We don't see the geometric horizon. So not P. We don't have a globe of radius 3959 miles. Is there anything wrong with that logical consistency?
Yes, there is. If not P, what was it? The Earth has a. Sorry, could you just repeat that? Because I was just getting.
Yeah, sorry.
Yeah, can you repeat that?
So, if P, the Earth has a radius of 3959 miles, then Q, every single geometric horizon distance can be no more than 1.22 miles times the square root of the observer height in feet. Yep.
Agreed. Yep.
And so the black swan image that we have shows a horizon far in the distance past 1.22 miles. This is at 1 foot. Even if you say it's 5 feet, the geometric horizon should be 2.77 miles. And so not Q, we do not have a geometric horizon at that distance. So not P, the Earth is not a globe of 3959 miles.
Okay.
So unless you assert that the globe has a bigger radius.
Exactly. That's what I was going to say. At best, what you have done, if that was all correct, at best you would have disproved the radius of the Earth, not that it's not a globe, not that refraction so on doesn't exist. But,
could you just put my camera up for a second, Craig? So this is not real, correct? We do not have a radius.
No, it's a real T-shirt.
That's a real T-shirt. That's my shirt. That's the one I'm wearing. You can buy it on Dome Life. PaulMcLean.com if any flat earthers would like to see it. And it's a take off that logo. Great band.
Well, should we move on to the next one then?
Yeah. So should we let Mitchell present his next evidence, if that's okay?
Okay. Yeah. Go ahead next. Yeah.
Over to you, Mitchell.
I've only got maybe about 10 minutes, so I won't bother doing my next evidence, which was I was just going to go back into the Black Swan anyway. So
Okay.
you can present your last evidence.
All right, over to you then, Mr. Sensible.
I thought you were going to do gas pressure without a container, but there we go. Okay.
I was,
All
but I realised that the Black Swan is such a good argument.
Okay.
that I didn't need another
But
argument.
guys, I mean, I know Mitchell only has a limited amount of time today. We can always reconvene at another day and carry on the conversation. I'm absolutely
Absolutely.
more than happy to carry on the conversation on another day. But Mr. Sensible, why don't you present your bit of evidence that we can go over
Okay.
now?
Okay, my second one is all to do with the sun at dusk and dawn. And I'll try and be quick so Mitch gets a chance to respond. At dusk and dawn, tall objects such as mountains and very tall buildings. At dawn, the very tops are lit first, and at dusk, the very tops are lit last. Beg your pardon, because the shadows cast up either from other things like mountains and so on, or from the shape of the Earth itself. Now, Craig, can I have image 1 up, please?
Yep.
This is the Burj Khalifa, and as you can see, the top 3/4 of it is lit. I'm not sure if this is a dawn or a dusk image. And then if we jump to image 2, which shows it even more strikingly, only the top quarter or whatever is lit by the rising or setting sun. So what on earth is casting a shadow onto the bottom 3/4 of the Burj Khalifa? Because if the sun is orbiting over a flat plane Earth, the further away it gets, the closer to horizontal it would be, but it would never, ever reach the point that the Earth itself, well, I mean, there is nothing there to cause the shadow anyway. And if we jump to YouTube clip 1, please, Craig, we'll watch about half of it because I think it just repeats. This is a time-lapse film. Thank you. Time-lapse film showing the shadows. Again, this is at dusk. The shadows climbing up the mountain. So that sun is light travels in straight lines, barring refraction, but that sun is casting a shadow which is getting up higher and higher on that mountain. And in a second, just there, you can see it coming up that snowy part of the mountain, leaving the tips of the mountains lit last. That can only be that the sun is lower than whatever is casting the object, be that another mountain or the Earth itself. And if we can jump on to YouTube clip 2, please, Craig. This is something I filmed outside the back of my house the other night, and it's sunset. You can see the clouds lit from below, and in fact, at the centre of the screen, you can see a wispy dark cloud, which is lower and is already in shadow. Looking to the blue area, the centre bottom, you might just be able to make out some white clouds, which are higher and further west, which are still in full sunlight. And then turn around 180 degrees, and all the clouds are in shadow. None of them are directly lit by the sun. Again, how can the sun light the bottom of the clouds unless the paths of light from the sun are going upwards to the bottom of those clouds? So, modus tollens for Mitch. If P, the sun orbits over a flat plane Earth, then Q, the sun cannot shine up onto the bottoms of clouds. Not Q, the sun does shine onto the bottoms of clouds. Then not P, the sun does not orbit over a flat plane. So there it is. I've done it really quick. So I'd appreciate any thoughts, Mitch.
Awesome. So, Craig, can you put up the image of the Black Swan?
Yeah.
So, Mr. Sensible, what are you claiming that line on the mountains is? Is that the geometric
It's
horizon
shadow.
on the line on the mountain? The
It could
shadow.
be.
What's blocking?
Yeah. I'm not sure if that shadow was from another mountain or was, maybe that mountain was stood alone and there was flattish plains in front of it. I don't know, in which case it's the actual body of the Earth. The point is, it's a shadow that is rising. It can only rise if the angle of the light source is getting lower.
So we definitely know that it's not the geometric horizon. So I think you've answered your question with what's causing the sun to be blocking maybe another mountain, possibly, or is it an apparent horizon that's blocking it?
In reality, it doesn't matter, Mitch, if it's another mountain or the geometric horizon. The point is, the light source is lower. If the light source is lower, how can a shadow cast upwards unless the light source is lower? Therefore, the sun has to be lower than those mountains, apparently, because it's setting.
Lower
because
than
it's
what?
dropping
Lower
below
than what?
than the mountains.
The curve of the Earth? The curve of the geometric
Yeah, it's
horizon?
gone round the curve. It's gone round the curve of the Earth, so the shadow cast by the sun is no longer a downward shadow. It's no longer a horizontal shadow. It's an upward shadow. Therefore, the light source has to be shining upwards, and that
But my point
cannot happen on a flat Earth.
Obstructed by a physical? Is it being obstructed by a physical horizon that I've shown that we do not have?
Yes, the light is being. No, you haven't shown that. The light is being obstructed. Well, the light has to be being obstructed by something physical. And as I said, it actually doesn't matter what that is and how far away it is. The point is, the light source has to be lower than the shadow to cast it upwards. And since the mountain is, I don't know, let's say that mountain is 10,000 feet, then that light path is not vertical, it's dropping down, which means the sun would have to be lower than that mountain because it's passing the curve of the Earth. And with those clouds, how would you explain the clouds then? There's no shadow on those clouds, it's where it is lit. So those clouds have a light source that is lower than the clouds.
Yeah, so it's a perspective issue, isn't it? Is the sun a physical object? Who knows? Is the sun have an actual location?
Oh my goodness!
Because we never.
Of course, the sun's a physical object.
Of course it is, but that's a baseless assertion because you'd have to go into how we get the distance of the sun. Craig has shown that before. You assume that the Earth's a globe. You assume that Venus is the same size as the Earth.
You don't need.
And you witness.
Sun.
So we witness the transit of Venus across the sun. So assuming all these things and using Kepler's third law, that's how we got. That's how we originally got and still do get the distance and size of the sun, assuming that it's we have a radius of the Earth, assuming that light in the sky, Venus, is an actual planet the size of Earth, something that we've never been to, something we can never get to.
Actually, we have been to. The Russians have landed landers on them. Venusian, I've forgotten the number, but they have landed things on there, and we can get. What's the word? When they, I can't think what the word is. When you examine the light of the sun passing through the atmosphere of Venus, we can see the constituent elements of that. And we've also taken radar pictures of the entire surface of Venus, I believe, with an orbiter.
Well, that's a lovely story, but yeah, you can't prove that that's where they've actually been. That's a baseless assertion. You're assuming that we are on a globe with a radius. You're saying that sun is being blocked by that geometric horizon, which I've shown in the Black Swan image. We do not have.
Sorry, what's that got to do with Venus? No matter what the shape of the Earth is, Venus exists. You can see the phases as it... the daylit phases of Venus. We have sent landers to Venus. We have sent orbiters that have taken radar imagery of Venus. And the same with Mars.
Venus? Whereabouts is Venus?
It's in an orbit around the sun closer than we are. It's an orbit around the sun closer than Earth is. Yes, in space. Are you going to deny space?
Is it in the vacuum of space?
Yes.
In a vacuum? Yes.
Yes.
Correct?
Yes.
Yeah, so that's a natural law violation. If we have a gas pressure here on Earth, why is it not filling the space?
Craig,
of space?
Can you put up a picture for me? So I'm just going to grab the number. Can you put up image 3 briefly? This is the Joint European Torus at Culham. It's a fusion reactor. Those are all magnetic containment fields. And if you can jump to image 4, please, Craig. This is a picture of plasma in, this isn't the jet torus, but is in another one. A picture of plasma being contained without walls. It's being contained by the magnetic forces. And Craig, I have YouTube clip 4, please, which is the Compass to Comac reactor. And if you jump in, I think about 40 seconds or so, it's fueled with, I think it's a deuterium-tritium mix, again, being contained in a magnetic container. There are no physical walls to hold it. And then when it reaches, I think it's called the Z point or the pinch point, we'll suddenly see the flash as fusion is achieved. But there you can see video of gas plasma being contained without walls.
Yeah,
Thank you.
To clarify what you're saying there, everything outside of that blue band is 10 to the negative 11 torr.
Yes, thank you. And
So
you've actually brought in this
by the fusion reactor.
It's being contained by the magnets.
That we're seeing?
It's being contained by the magnets. It's not touching the walls. And
Why can't we
think
just?
of our,
Why does it have to have walls? No, can I just say why does it have to have
because
walls?
you guys
Can we
keep
not
saying
do
you can't have
just
gas
normal-
pressure without a container. What I'm
You've
demonstrating
clearly
there,
got a container. It's being contained
Magnetic.
inside the fusion reactor.
yes, but it's not touching the fusion reactor. The gas is in a vacuum. It's being contained in that band by the magnetic forces, just as the atmosphere on Earth is contained by gravitational forces. When you think, if you think of, look at the weather, and if the air pressure where you are is 1,001 millibars, and then a few hundred miles away it's 1,010 millibars, those are different levels of pressure. The gas pressure, the atmospheric pressure will try and equalize. That's why you get wind. Now that's going horizontally. Bottom of Everest, we got atmospheric pressure at sea level of 14.7 psi. At the top of Everest, we got 4.89 psi. That's massively difference between weather patterns, and yet we don't see all the air rushing up to the top of Everest. Do you know why? With one, it's equalizing horizontally.
Because we have gas pressure.
At the same gravitational
Because we have
force.
gas pressure in
The other one, it's fighting against. It would want to equalize, but it can't because it's being held down by gravitational forces.
Yeah. So I think Mr. Sensible's
your
claim here
argument-
is that there is no physical barrier between the area of ionized gas pressure and the vacuum right next to it. Obviously, we have to put the vacuum in a container because that's how you make a vacuum. But the claim of the second law of thermodynamics is that you can't have a high pressure system next to a low pressure system. Is that correct? Yeah. But this is a high pressure system next to a low pressure system without a physical barrier between the two of them, showing
Well,
that they're.
But when you
My
come to
assertion
Earth's
is you cannot
atmosphere,
have gas
Mitch,
pressure without a container. You cannot
But
have
that-
gas pressure without a container. Or a vacuum. for
okay,
that matter. You can't have
and I
vacuum
agree.
without a container.
I would agree that there is the plasma at pressure with a container. So you agree there is a container. It's a magnetic container. It does not have to be physical. And the thing is, what you don't have 14.7 psi atmospheric pressure next to the vacuum of space. You could drive up a hill, there'll be lower atmospheric pressure. You go up in a plane, it's lower still. When Felix I can't say his name, Baumgartner, went up to 128,000 feet, I think it was, there was a pressure there of 0.036 atmosphere. There is no membrane between that height and ground level. There's no membrane between the top of Everest and sea level. And yet, we do not see equalization. The reason is there's a container. Gravity. Ask Desert File.
That's fantastic. Can I point out that at 120,000 feet, there's also no curvature, as shown by that camera as well.
Well, I
The
didn't.
lens
I
distortion,
didn't
but
mention about
absolutely.
that. I didn't mention that about Baumgartner
That's fine.
because that's
That's
a
fine.
whole
I'll go
different.
back to your
That's a
argument.
whole different issue. It's just the
So
pressure.
gas pressure gradient. Gas pressure gradient is a delta of gas pressure. In order to have a gas pressure gradient, you first need to have gas pressure. So
Yes,
gas
but
pressure
atmosphere
can
is
only
atmospheric
exist-
pressure. It's not gas pressure.
Sorry, what's atmo?
So,
Air. Air is still the atmosphere. It's made up of gas molecules.
yes, but it's a different cause. It's a different cause. The cause of the pressure is the weight of the atmosphere above.
No,
and the reason the atmosphere
what
above
about the
has
cause of the
weight
gas?
is gravity. Sorry.
What about the cause of the? So you're saying that gravity is the container.
Yes.
So how is it containing it?
Yeah.
Is it a force?
It
An
doesn't matter
emergent
if it's a
force.
force or effect
does.
or unicorn foot. Well, you can think of it as a force. Yeah, you can think of it as a force.
I know
you can take
can.
gravitational. You can take the gravitational equations. You can plug the figures into it. I know that Newton actually thought it was a force, something physically pulling, and it appears he was wrong about that. But his equation still holds good. We use his equation. You plug the figures in, it works. Science works.
They're not interchangeable.
Do you mind if I ask a quick question, Mitch? Why is that gas pressure not rushing to fill the vacuum?
Which one? So
In the picture in front of you, that area of blue is a gas pressure. Outside of the blue is a vacuum. So why is that blue gas not rushing to fill that entire container, which is a vacuum?
Because it's a beautiful example of a gas pressure gradient inside a container, is which we have all around us when we breathe. We're inside a container with a gas pressure gradient. If I'm allowed to respond to the container of
where is the container? That's postulated. We've never seen it, measured it, touched it. No. Sorry. Yes, in the reactor. We've got the magnetic container within the physical container.
Yeah, can we have a picture of that ionized gas being outside of a container next time, instead of inside the container of the fusion reactor? So to have gas pressure in the first instance, we must have a container. It is a necessary antecedent. You cannot have gas pressure in the first instance without a container, and you can have a gas pressure gradient inside the container.
Mitch, are you not listening to us though? We agree for gas pressure, you have a container. For the atmosphere,
end of
atmospheric
argument.
pressure.
That is my argument.
But you have said, with regard to Venus, and I presume Earth, that the atmosphere would rush off into the vacuum of space. It would, but for the fact it is contained.
Absolutely.
It is contained by gravity. If you're proposing any other container, such as a dome, I'm not trying to say you're saying it's a dome, but such as a dome or other container, where the hell is it? We've never seen it, touched it, measured it. And if there is one, how do things like comets and meteors and whatnot, how do they cope with a physical barrier between us and beyond? Or are you saying the atmosphere is space?
The lights in the sky don't really concern me. What concerns me is there being gas pressure that we have, and the necessary antecedent for the gas pressure is the container. Now, by you saying that we have never witnessed the container, saying that we do not have gas pressure here that we're breathing. Now, I'm going to have to leave it there because I do have a time constraint. I have to go to work, so we'll have to continue this another time.
Yeah, absolutely. Guys, I'm more than happy to host another conversation with you to carry this on. And Mitch, I'd like to have a conversation with you about the gas pressure claim, because I can absolutely demonstrate that you don't need a physical barrier because energy can be a barrier. But that can be another conversation. But if you guys contact me, I will.
Can you show something? Cool. Can you show something without a container next time, though? That'd be.
The main point of this is that the vacuum within the reactor is an analogy for the vacuum of space, and then that blue band is an analogy for the atmosphere of the Earth. And what we see is that blue band isn't rushing to fill the vacuum.
Do we have a container in space to contain the vacuum?
The universe.
Yes,
like
gravity.
The fusion reactors being contained.
We got gravity.
Got it.
Yeah, no, I mean, Mitch's question there was, do we have something to create the vacuum? And yes, we do. The universe is the entire system that the vacuum is in.
But gravity, the non-force force that you can think of as a force, that's a concept of the bending of the conceptual medium.
Do you know what the phrase emergent?
Step off a building, Mitch, and see what happens.
Do you know what the phrase emergent force means?
No, I think you're going to have to explain your claim.
Cool. We can go into that on the next conversation. I know you have to get off, and I know you've got work.
Absolutely.
So I don't want to hold you back.
I've got to run.
I want to say thank you for having a decent conversation. It's been a pleasure to have you on the channel. So thank you for
Thanks, Craig.
thank you very much.
Sensible. Great conversation.
Cheers, Mitch. You take care, pal.
All right, I'm going to speak to you later, Mitch.
Thanks, mate. Bye.
Bye.
Bye-bye.
Right, Mr. Sensible, I think you did pretty well there.
Oh, thank you. I enjoyed that. I really did. And I want to take this opportunity, Craig, of personally thanking you for hosting this. I really, really appreciate it.
No worries. I'm always happy to do it. There were so many times that I wanted to jump in, but I know the conversation was between you and Mitch, so I was trying my hardest not to.
But when he invited you in, I was cool with that. That's excellent.
Yeah.
But I don't think we came to a firm conclusion. Although it was interesting, I thought that with the whole star rotation thing, I want to say he conceded. I don't want to put words in his mouth, but he had no explanation anyway for 2 points of rotation in the sky.
Mm-hmm. Absolutely. Before we get off, I just want to say, guys, Channel Q, I think a lot of you are probably aware of her. She put up a video recently on her channel that I thought was absolutely fucking hilarious, which is Nathan Oakley talking about the Black Swan argument with Brenda. So guys, if you want to go and check out Channel Q's most recent video, I thought that was absolutely hilarious. If anyone of my mods want to grab that and chuck it in the chat, that would be great. But yeah, so I thought that was a decent conversation. I enjoyed the dumpster fires. I mean, who doesn't? But it's always nice to have a decent conversation where people can, actually converse back and forward, not shouting over each other. So yeah, thank you to you, Mr. Sensible, for behaving yourself, because globe heads can be just as argumentative as flat earthers.
But to be fair to Mitch, in all my dealings with him, he's always been reasonable. I mean, we talked over each other a couple of times, but you've always got the time delay, which doesn't help.
Yeah, exactly. He's damn globe and speed of light, hey?
Yeah, yes, that's right. Can I just say though, and this isn't a shill for my channel, but tonight I do have a video coming out which has my clip with that ball and the lens and the refraction. Mm-hmm. I have a video coming out with a breakdown of it, but a second video which is just the clip itself, which I am more than happy. In fact, I would welcome people mirror and use in arguments.
I will be using that.
Thank you. And I'd like it if all I ask is it's not edited. I mean, if you show the whole thing and then show edited, that's fine, because the point is it's one shot. So there was no trickery. And obviously anyone who uses it, just to link back to my channel, would be appreciated. That'll be on my channel about 9:15 tonight. So
awesome.
Anyone's welcome to use it. Let's shove that black swan down their throats.
Yeah, I mean, the apparent horizon is what we see. No one's denying that, because atmosphere's there, therefore there's refraction. No one's denying that there is the apparent horizon is what we see. You don't see the geometric horizon unless you have the K value that is, as it says, the tangent to Earth's surface, observer, and radius of r, a curvature of infinity, which requires 1 over k equals infinity, so k equals 0, which gives no looming. So in those specific circumstances, you will see the geometric horizon because it matches what the apparent horizon is. But refraction happens. No, I mean, you wouldn't know, really, unless you measured the density of the air and everything and calculated the K value for yourself based on the coefficient of refraction and lapse rates. I mean, I've been doing a lot of studying around the mathematics of this, and I would love to go over that with Mitchell or anyone who's claiming that the Black Swan is a globe killer, because I can literally talk you through the maths to say why it isn't. Maths is my strong point. It's what I do. I've got a degree in physics. I've studied my whole life to be good at those things. So if anyone wants to have a conversation about the Black Swan, I can talk you through the maths of what we are seeing. One of the issues about the Black Swan and the image that they bring up is that we've got no references to what it is. No one's telling us what the temperature of the water was, what the density of the air was. We don't have those things, so I can't do the calculations based on that. But I could reverse engineer based on what we're seeing. I could reverse engineer and give you an approximation of what the atmospheric conditions are based on the distances that we're seeing, because the maths is easily there to do.
And looking at platform habitat on the left-hand side of it, that crane or whatever it is, it's twisted out of all shape. And actually, on the right-hand side of it, the I don't know what it is, the block they live in or whatever. Look at the height of that, and then the height of on platform Hill House. You can see how it's stretched up.
Exactly.
It is basically all distorted. And as you said, without the accurate figures for the temperature gradient, you don't know what you're looking at.
Yeah. Absolutely. And I could see Red Pill Philosophy in the chat, obviously taking a break from saving the Mushroom Kingdom. Red Pill Philosophy is still running away from debating me. It has now been 126 days, 19 hours, 20 minutes and 40 seconds since he refused to debate me even on his channel. And do you want to know his reason for refusing to debate me? Is because he calls me a Nazi book burner, because I agree with YouTube's decision to do whatever the fuck they want with their own platform. If they want to suppress Flat Earth videos in the algorithm, that's their platform. They can do it. It's not owned by the government. They don't have to answer to anyone. There's nothing Nazi-ish about that. I would be the worst National Socialist in the world. So, Red Pill Philosophy, you have no reason to not debate me. I will do it on your channel, with you having the power of muting. I don't care.
Wow.
Mario, I will take you down. Just stop being a baby and agree to debate me. And also, Sleeping Warrior was hanging around in the chat.
Was he now?
Yeah, he refused to debate me because I am a liar about gravity, because I call gravity a force. Sleeping Warrior, gravity is not a physical force. It is an emergent force, an emergent property of something else happening, a consequence of the curvature of space-time due to the uneven distribution of mass. I'm not ever going to say that gravity is a physical force, because it's not. It's an emergent force, an apparent force, a fictitious force. Doesn't stop it being a force. So both of you, Sleeping Warrior and Red Pill Philosophy, I will take you both on at the same time on someone else's channel. Stop being cowards.
And actually, Craig, a long time ago, I asked Sleeping Warrior for a debate. I think I had about 400 subs at the time, and he said no, because he wouldn't want to make the same mistake he made with someone else and give them the publicity and all the subs. Well, Sleeping Warrior, I'm now at, I forget what it is, just over 4,000. I'm not far behind you now, mate. I'll be overtaking
I think you might have more than Sleeping Warrior. Let me just check. Sleeping Warrior, 4.53. Mr. Sensible.
I think I'm 4.06 or something. But he hasn't got much.
Yeah,
chance
you're about 400 behind.
Yeah, and of course then I'd be unlikely to debate him because I wouldn't want to give him the publicity.
I'm more than happy to give Sleeping Warrior or Red Pill Philosophy the publicity. When me and Sleeping Warrior last debated, I had about 5,000 subs. I've now got about 23,500. So I'll give you that publicity, Sleeping Warrior. I mean, I've done 8 videos about how stupid you are. So, yeah, Flat Earthers, most of them are cowards and will do anything in the world to avoid a debate, which is why I actually appreciate people like Mitchell from Australia, who is willing to come onto the channel. All right, I say he's completely wrong about everything he says, but at least he's willing to come onto the channel and act like an adult. I mean,
sorry, Craig, who's that? I just had a dropout then.
Mitchell from Australia. I'm saying, he's decent. But then, if you look back at the a debate I had a few days ago on Saturday, where I had Sonny Stephen and I had the Plain Truth on, those were 2 examples of different attitudes. The Plain Truth acted like a child, talked over, shouted, pouted, was a general dickhead, whereas Sonny Stephen was a decent person that I could have a conversation with. A lot of Flat Earthers just don't understand how conversations work.
You had a second debate with him, didn't you?
Yeah, I invited Sonny back on because I enjoyed the conversation, and I think I can save Sonny. I think 2 or 3 more conversations, he won't be a Flat Earther anymore.
Nice one.
Yeah.
We'll save them one at a time.
Exactly. Before we shut down, Mr. Sensible, any final thoughts?
Well, as I said, big thanks for hosting this. I really, really appreciate it. Anyone who hasn't come across me before, please have a look at my channel and then consider subscribing. But even if you don't, as I said, later on tonight, I've got a breakdown of my refraction video, and then the video itself as a distributable clip will be coming up at the same time. Please, please get that spread around.
Mr. Sensible's channel link is in the description. Please, guys, go and give him a sub. He most definitely deserves it. He somehow debunks the flat Earth with cheese.
Yeah, and even today,
nice.
With cheese.
Always what you need. I had a few super chats come in. And guys, as always, I could not continue to do what I do without your support and your generosity in the form of super chats and channel memberships and patrons. So from the bottom of my heart, thank you so much. It means the world. But I also, every single one of you that watch, that like, that share, you help my channel just as much, and just you guys supporting me means the world. If you're not able to support me financially, I don't care. Just share my stuff and help my channel grow, and I appreciate everything. So we've got Lucia and Andreas for 10 rons. Thank you for the Weasleys. I predict this stream will be cheesy.
It was cheese.
Yes. Sergsy for $5 Australian. Sorry if I got your name wrong there. Australian Flerfs? Nonsense. Yeah. It blows my mind that there's people from Australia that are flat earthers. I mean,
Yes.
Sigma Octanus destroys the flat earth.
I know.
But General E. Shady for $2 Australian. Mitchell rotates on a pole. And then General E. Shady for another $2 Australian. Mitchell, go south, sit on the pole, rotate. And then we got the Snark for €2. That was fun, guys. Yeah, I had a great time. Thank you everyone for joining. I really do appreciate it. Make sure you subscribe to Mr. Sensible. I will have a new video out. What's it today? We're on Wednesday. I'm going to have my new video out on Friday, which is a anti-vax video, because they're even more dangerous than flat earthers. I mean,
definitely.
Measles
People
was
die.
like eliminated across the world, but thanks to the anti-vax movement, it now exists again. And anyone who doesn't get vaccinated or doesn't vaccinate, if you're a parent and you don't vaccinate your children, you don't deserve to have children. You're putting that child and everyone else at risk by being a fucking idiot. So yeah,
Look at how many people
video-
are coming down with mumps now, Craig.
Exactly, yeah. Like it's ridiculous. So yeah, I'll have that out soon, and then I'm going to redo my Mark Sargent video because I was extremely unhappy with the audio quality because I was having issues with my computer. But also ITV have copyrighted it and removed it from being seen by anybody. So I'm going to redo that one and release that probably in the next week or so alongside the other stuff that I'm doing. I've got a debate on Saturday with a guy called Flat Earth Science, like there's any such thing, who thinks that people are following him around and beating him up because he says the Earth is flat. So that should be fun. Mr. Sensible, like I said, he's got his video coming out tonight, guys, so that you can check that out. One more super chat's just come in, $2 from Sirf. Late super chat because I was late. I forgive you. I still love you. But we're going to shut down for tonight. Thank you, Mr. Sensible. Thank you, Mitchell from Australia. Thank you, everyone, for watching. Even you coward, mustachioed moron, red pill philosophy. I do understand that if you are unable to debate me because you're busy saving the Mushroom Kingdom, but I must ask you some questions, so we need to have a debate. And Channel Q has just popped in. Yes, you are late, unfortunately, but I did give your video a shout out. Feel free to post a link and I'll make sure it gets shown because Channel Q is actually hilarious. And I want to give a public apology to Channel Q while I'm here and while she's there, because when I first started my channel, Channel Q and P Mars came on. P Mars is a dick, and I'll never say sorry to him. But I was horrifically nasty to Channel Q, and I was wrong. And I publicly apologise for the way that I treated you, Channel Q. I've got nothing against you. And please continue to do what you do. Okay? But guys, that's going to be us for tonight. Thank you very much for joining, and we will see you all soon. And remember, stupidity is not a right. Fight the flat earth. Fight the flat